Hello and welcome, my name is Ryan, I'm also known as RM2K Dev. Today we're going to be doing a tutorial on kind of project structure, saving and loading. Now this is something that when I first started making games in GameMaker I struggled with. There wasn't that much documentation out there for really how to deal with variables that need to persist through your game. So say for instance you've got a character, it's moving around the screen, it's collecting chocolate eggs, because we're kind of in the lead up to Easter, and you teleport out of that room into another room. First of all, how do you keep the number of chocolate eggs available to the character so that the objects don't just reset? And second of all, how do you save and load between sessions? So for instance, obviously you've closed the game, you've opened it again, and you press the the load button, and suddenly everything comes back in and the game is back up and running. So let's get started. So first thing I'm going to do, I'm just going to create some sprites. Let's just create one called SPR egg. And of course the graphics in today's video are going to be super fantastic. I'm just trying to create a little demo. Just put a little E for egg in there. So that will do, and I'm just going to center that. And then let's just create another sprite. I'm just going to call this one SPR player. And we'll just put a little, I don't know, just put a yellow circle with a P for player. Now I know the graphics are amazing. I'm going to win awards, indie awards for this kind of graphic art here. I'm just kidding. So there we go. We've got some graphics set up, very basic. I'm just going to add an object, just call this one obj_egg. I'm going to give it that sprite, the egg sprite. You know what? I'm just going to change that one more time. I want to put a color around it just so that we can actually see this on the map. Where's my flood tool? There it is. Cool. So that'll do. So now we've got the egg, and I just want to create another one, obj_player. And we'll give that the sprite of the player. Now obviously, graphics aside, this is a kind of basic example. I'm going to throw the player on the map, and then I'm just going to put some eggs, kind of around the player on the map, just so that we've got something to collect. There we go. Alright, so real basic now. Let's jump into the player object and allow them to move around. So here's a very basic input system. I'm just going to jump into the step event. I'm going to get rid of the comments over here. And let me just zoom this one up for you so you guys can see it a bit easier. Let's say in here, input x equals keyboard. I'm just going to use a keyboard check, vk left. Okay, so now that we have keyboard left, we're going to multiply that by -1. Which basically means if the left button is pressed, true or false. If it's false, anything multiplied by 0 is 0. If it's true, it'll be multiplied by -1, and so the value will become -1. And then I'm going to add to that the result of keyboard check. Sorry, keyboard check vk right. So basically, if we're pressing left, we're going to be moving left. Because true, which is 1, multiplied by -1 is -1, and then obviously if we're not pressing right, then it is false. False is 0. Or we're pressing right, and right is true. Therefore, right is 1, which means that it'll be 0 plus 1, which means the result will be +1, and we'll be moving, and our character will move to the right. And we'll do the same thing for input y. So we'll just create two variables. This one here will just be vk. I think down is negative and up is positive. So we'll just do vk down and vk up. And then all we have to do is just say x plus equals input x. And we'll just multiply it by, I don't know, 4 to give it a bit more speed. Y plus equals input y times by 4. And just make sure we adjust our variables to suit. So if I run this game, we should have keyboard movement now. At least in a very basic way. I got my ups and downs mixed up. So all I'm going to do to change that is just change this one here to VK up and this one over here to VK down. So a very quick input system, just gets you up and running. You don't have to go through doing a bunch of if statements and all sorts of stuff. But it's not pretty, but it kind of works just for this kind of example. So there we go. We have a basic input system. Now we want to make it so that when we collide with the eggs, we score some points. So what I'm going to do is I'm just going to add a collision with egg. And in here, I'm just going to say destroy, not destroy, instance, destroy, and it will be instance, destroy, and the ID is going to be other. So the thing that we collide with is going to destroy itself. So let's just make sure that that's working, so that when we collide with these eggs, they now get sort of eaten by the player. There we go. That's the basics of our demo. Also, guys, I want to apologize for the voice. I'm still kind of sick from a couple of weeks ago. Just seems to be hanging around. So now we've got this ability to walk around and touch these eggs, and we'll capture the egg. What we need to think about now is the persistence of data, either across rooms or throughout game sessions even. So I'm going to create another object. This one doesn't need a sprite, but we're going to call this obj, actually, we're going to call it game state, like that, capital G, capital S. And this time I didn't put obj because I'm not going to be referencing this in the game like an object. I kind of want this to sort of exist like a class in traditional programming throughout our game. Now in our create event, I'm going to add a score variable equals 0. Actually, I won't call it score, we'll call it egg count. Egg count equals 0. And then what I'm going to do is I will create a draw event. I'm just going to say draw GUI. And in here we'll say draw text at 0, 0, and actually I'll put that at 10, 10. Makes it nicer if it's a little border. I'll just say score, also eggs. And then we'll just say plus string, and we'll put the egg count variable. So basically what will happen now, when this is on the room, we'll get a little score counter in the top left-hand corner, just to tell us how many eggs that we've got. So we've got 0 eggs right now. So now what we need to do is we can go over to our game state variable here, and we can begin to adjust this egg counter and also create a way to save and load information. So first thing I'll do is I'm just going to create a key released function, key up, there we go, and it's going to be what key is it going to be? It's going to be a letter, and we'll do S for save and L for load. So this is save, so I'm just going to change save, just for a placeholder for the moment, and we'll add a keyboard up letters, and this time it will be L. This one is going to be load. Alright, so now we have a way of saving and loading information, or at least a placeholder to do it. Now, this egg count thing that we just created, as simple as that was, that's not the way I actually wanted to do it. I just put it in there so we could have the text appear on the screen. What I want to do is I want to use a DS map. Now, the reason I want to use a DS map specifically is because that gives us a key value relationship between two pieces of information, and I'll just pop it up in the help file. It gives us a key value relationship between values and keys. So you see we have an ID of the map that we're using, we have a key and a value. So for instance, the key could be storing a value like player's position, player's name, number of eggs captured, number of hostages saved, whatever your game is doing. Has player completed quest X, Y, or Z? Achievement unlocked, true or false. All these different values can be added to a single map within your game state, and that's the reason that I've called this variable game state. And they can be referenced. They can also be serialized and deserialized. They can also be saved and loaded. There's a function here called dsmap secure save, which takes a map and it will output a file based on the contents of that map. Now, the map can then be encrypted so that it can only be loaded on the same platform, and this works across all different platforms. So this is going to work on your iPhone, this is going to work on your Steam games, this will work on PC, Mac, Linux, wherever you want to run your game. Even I think HTML, this function still works in some capacity. So basically, this is what's going to allow us to just dump the entire contents of that map out into a file. So in our create event, I'm just going to change this a little bit. We're going to say game state.state. So we'll say state equals ds map create. There we go. Then what we're going to do is we're going to say a ds map add, and the ID is going to be state, and the key is going to be eggs, and the value is going to be 0. So a very similar thing to what we've done over here, but just a little bit different this time. So now we can get rid of this. Now we can go back into our draw GUI function. We can change this to ds map. I think it's find value. There it is, find value. The ID is going to be state, and the value we're looking for is eggs. Right? So very simple shift in the way that we use a traditional variable to the way that we use this sort of database kind of variable, or the map variable. Now, if we run the game again, assuming everything went correctly, we should still have eggs 0. Now, getting into the meat of the tutorial, let's make it so that once we have collected an egg, our score goes up. So in our player object, in our collision with an egg, just before we destroy the other egg, what we're going to reference is this game state. We're going to say game state. Now, because it's an object, even though it's an object, because we've named it kind of almost like a class, it's going to function as if it was a class. What I mean by function by a class is that we're going to be able to reference it, we're going to be able to use the code that's inside it. So we have this GameState.state variable that exists, and we also can directly access it now. So we can say ds map, we can say add, or we can do find and update. Let's have a look at the functions. ds map. Let's do ds map add, or there we go, ds map replace. So we'll do ds map replace key with value. So what we need to do is we need to know how many eggs we currently have. So we'll say current eggs equals ds map find value. The ID is going to be GameState.eggs. Sorry, GameState.state. The key is going to be eggs. There we go. So we've got the eggs out of the system now. Then we can replace GameState.state key of eggs, and the value is going to be current eggs plus 1. I'll put that in brackets just for math isolation. All right, there we go. So basically, what we've got here is a really simple system. It goes and finds out how many eggs you currently have, increases it by 1, and replaces it by that amount. Now, technically, if we collide with these eggs now, you'll see that our egg counter is increasing by 1. But this is all happening within the context of our DS map, which means that when we save that DS map and when we load that DS map, the egg counter will save with it and it will load with it as well. So heading back over to our game state, let's implement our save and our load. This is very simple now because we've already dealt with DS map secure save and secure load. So there we go. Secure save, we're going to save out state. The file name that we're going to save it to is state.dat. I'm just going to call it dat for data. And in the load function, we're going to use dsmap secure load. And this time we're going to load it into state. Actually, no, we're not going to do that. We're going to go into states.dat. .dat. And we're going to say that state equals dsmap secure load, because this function returns a dsmap object. So if you see this one here, it returns a dsmap. There we go. So whereas the save function doesn't return anything, we need to tell it what are we saving and where are we saving it to. The load function simply loads a file and returns a dsmap, which we're going to put back in state. Now, state already is a dsmap, and since our draw function is referencing that, it shouldn't affect the system at all because it's already there. So let's walk around, let's collect some eggs, then we're going to hit S for save, and then we'll collect another egg, and then we'll hit L for load, and you'll see that my egg count has gone back to 2. Right? That's good, but what we really want to do is make sure that it loads when we close the game, when we open the game again. So I've started the game afresh, I have 0 eggs. If I load my game by pressing L, you'll see that I now have 2 eggs. Now this is awesome. This is a really simple way for you guys to just create a persistent game, a game state that exists across rooms. As a matter of fact, before I sort of finish up the tutorial, let's just quickly throw this in. I haven't planned this bit out. I'm just gonna hack away at it and show you how it works. But we have a player in a room. What happens if we take that player to another room? Let's create a room. I'm going to just call it room 1. That's fine. I'm going to put the player on that room, and I'm just going to make it obvious that we are in room 2 by kind of just drawing a number 2 with eggs in the top corner. Oh god, what am I doing? This is my dodgy drawing of a number 2, so please forgive me, just so that we know where we are. There we go. And I'll put an egg or 2 near the player just so we can pick them up as well. Right, so in our room 0, which is where we start, and then in our room 1, there's a difference. Now, in a traditional sense, what you would normally do is you guys are probably normally, putting all your objects into each room, and we need a way to get there. But so I'll just make it so that when the player presses, I don't know, the character on their keypad T for teleport, that is, when the character presses T, we're just gonna say room go next, because the next room in line is going to be room 1. So when the character presses T, it's going to take us from room 0 to room 1. One thing you're going to notice immediately with this kind of traditional game maker style of programming is that if I collect a bunch of eggs and then I move on to the next room, our eggs reset, our character position resets. So how do we maintain that information across rooms? Well, the answer is really simple. The answer is with this game state object that I've created. So I've just deleted that from the second room, and I've put it in the first room over here. This all just comes down to kind of the flow of information and the order of the order that things are created in and the way that you access the information. So in game state over here, we have this option to tick this box that's called persistent. What that means is that when the room is destroyed, as in we move on to the next room, anything that's persistent isn't actually destroyed. It remains in its exact current state. It remains in its same X and Y position. It remains with all of its variables. It's just physically not destroyed. It's almost as if you created it and it existed throughout the game forever until you destroyed it yourself. So that's what the persistent tick box does. Now, in doing that, we've got the option now to set up our variables in what I would call an initialization room. And you'll see a lot of games doing this. You'll see they have a start menu, they have a loading screen. All of that is a game developer going out of their way to initialize things in a way that makes sense for the structure of their game. So I'm going to add another room, and I'm going to call this init, just for initialize, and I'm going to make it the first room in our game. Then in our other rooms, I'm going to delete the player, and I'm going to delete the game state object, because we don't need it to exist in any of our game rooms. Now, over in our init room, which is our initialize room, I'm going to add the player, and I'm going to add the game state object. Now, the other thing that we need to do is go to our player and also enable the player to be persistent. And then finally, in our game state, I'm going to say on create, after it's done all the things it needs to do, we're going to say room go to next. Okay, so what does this all mean? So keep in mind that when the game state object is created, it immediately moves to the next room. Our player object is persistent. Our game state object is persistent. With them both being persistent, that means that in our init room, we're going to start the game by going to our init room because it's the first in our rooms list. Our game state is going to be created, our player is going to be created, and then immediately we're going to be moved on to the next room, which is this room. Now, our player has the logic that when it collides with these eggs, it then adds to its score, and then when we press T, it moves on to the next room. Now, because the game state and the player are persistent, we are both going to retain our score as we transition between rooms. We're going to retain our position as we transition between rooms. And we're also going to have the ability to save and load our data across the entire game. So if I run this and move the character about, you'll see immediately, you didn't see it because it's just not visible, but we were in that init room. Our egg counter is still existing. Our player is still on the screen, but we're suddenly in the second room. That's because we immediately transferred there. So let's walk around and collect some eggs. So we've got 2 eggs. Now if I press the T button on the keyboard, you'll see we've teleported to the second room, which you can see because of the identifying eggs in the shape of 2, but we still have 2 eggs. And if I go over here and collect a bunch of eggs, we have 12 eggs now. And if I save my game, collect a couple more eggs, so that we don't have 12. Now we've got 14, and then I load my game, we've got 12 eggs again. But now if I close the game and restart the game, and then pretend that I've continued on, you'll see that we now have 12 eggs again when I load the game. This is kind of the basics of the flow of information in your game. This is kind of how you should be organizing and structuring your game, creating systems that work throughout the game. So game state is a system. It's a place for you to store information. It's a place for you to save and load information. I've just bound it to keyboard events over here because it's quicker to get the tutorial just to give you the main piece of logic. But when you're creating your game, you can bind this to menu items. You know, so you press escape and go to save, or press escape and go to load, or you're making an RPG and you talk to the little glowing crystal orb thing that exists on the map right before the boss. So you know the boss is coming. But you know, wherever you put it, it doesn't really matter. The point is that the data that you put into that map will save. You could put other kinds of information in there. You could put, you know, achievement statuses. You could put player positions. What map is the player on? And then, instead of doing what we did where we just load the information out, in the load event, you're able to actually process that information to say, you know, teleport. Oh, you wouldn't say teleport. You would say, you know, I'm just going to write this in comments because I'm not actually doing it, but you would write something, you know, similar like saved room equals ds map find value state, and the value might be, you know, current room. You know, so now you know the room that the player was in. You might have like saved x equals and saved y equals, you know. So you've got these variables now. Then you could do something like room go to saved room, and then you could do, you know, player.x equals saved x, saved x, and another one, you know, player.y equals saved y, you know. And very simply and very quickly, you've got a generic system that allows you to save, load, and process all of this information in your game. This kind of basic pseudocode here is going to allow you to save the player's position. Not only when you save it, when you load it, it's going to come back and take you to the room that the player was saved in, put you in the same position that the character was, and, you know, the same facing direction, you know, whatever your game is doing. So, very basic system, very powerful concept. Thank you guys for watching this video. I hope you've enjoyed it. Please don't forget, I have got a Patreon going now where you guys can get access to the videos early, as well as the source code will be available for download in those videos. I really appreciate the support. Thank you for helping make the videos possible. And again, sorry this one was a little bit delayed. Still a bit sick, but getting better now. So back on the mend. Videos will be coming out weekly from this point, as per usual, I believe. Thank you for watching, and I will see you guys next time. Take care, and bye for now.